Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the magnetic field due to intersecting cylinders. So you can see there are two long cylinders which are carrying equal current, and let us suppose that the current in the first one is I and the second one is I but in the opposite directions. So they are having some common intersecting region, and we have to find out the net magnetic field in this intersecting region. So let us first, and it is also given that the distance between the centers of these two cylinders or the axis of these two cylinders is A. So let us first of all individually draw the magnetic field circle of any one cylinder. So let us suppose that this is a point P. I'm not assuming the point P on the bisector line. In fact, I am assuming it at any point. And this angle is alpha. So if I draw O1 and I connect it with P, and this angle is alpha, obviously, so the magnetic field, as the current is coming out of the plane, so magnetic field will be like that. Okay, and this angle will be also alpha, and this is 90 minus alpha. Now let us suppose that this magnetic field is B1. So B1 is equal to mu naught J. Now J will be same because I have assumed that cylinders are identical and current is same. So mu naught J, and this distance is O1P divided by 2. Okay, and in the same way, if I draw the magnetic field circle of the second cylinder, then current is inside the plane. Then if we connect P with this point, this is O2 and this is P, so the magnetic field will be like that. Okay, if in fact magnetic field will be in this direction, B2. So if we suppose that this angle is beta and this is beta, so B2 will be equal to mu naught J is same again, and this is O2P divided by 2. Now if we divide these magnetic fields into components, then this component will be B1 sine alpha and this component will be B2 sine beta. So if we just talk about B1 sine alpha, so B1 sine alpha is mu naught J by 2, and this is O1P sine alpha, and B2 sine beta will be equal to mu naught J by 2 O1P sine beta. Now you can see that if this height is h, so you can see that O1P sine alpha is h and O2P sine alpha is also h. So we can say that the net magnetic field will be cancelled out, as B1 sine alpha will be equal to B2 sine beta in the x direction. But in y direction, if we find out the components, then these components will add up. So in y direction, B net will be equal to 2. In fact, it would be equal to B1 cos alpha plus B2 cos beta. Now B1 is mu naught J by 2. I'll take it common, and then it would be O1P cos alpha plus O2P cos beta. Okay, and you can see that O1P cos alpha plus O2P cos beta is A. So this is A, and therefore the net magnetic field will be mu naught J A by 2. And this magnetic field is initially pointing in upward direction, as well as it is constant in magnitude, because A is the distance between the axis of the cylinders, and it is constant. So we can say that in this complete intersecting region, the magnetic field is constant, and we can draw a diagram like that in this intersecting region, if current is same and it is in opposite directions, this is I, and cylinders are identical in shape and size, and we can say that in this intersecting region the magnetic field is constant, and this magnetic field B is equal to mu naught JA by 2. So this is the final result. Thank you.